Hi everybody! Welcome back to day 3 of our 6-day Python tutorial. Today we are focused on problems of reading text files particularly, because as you recall, the project we are writing in this 6 tutorial session is a FASTA file reader that counts the number of entries and that determines the number of times each amino acid appears in the sequences. So I am starting with a piece of art. Now, I didn't take art history in high school, I must say, but even I had heard of René Magritte, who is an artist from Belgium. Does anyone here speak French? No French? No French? Am I the only person who took French in high school? Ah, well, there you have it. So here we have the words "Ceci n'est pas une pipe," which you should immediately translate in your mind to "This is not a pipe." So why would Magritte paint a pipe and then write the words "This is not a pipe" right beneath it? Anyone get this? This painting was called "The Treachery of Images" because René Magritte really likes this idea of logic puzzles in his slides. In his paintings. So he's written "This is not a pipe" because he wants you to be cognizant of the fact that this is a painting of a pipe. So it may represent a pipe, but it is not in fact a pipe. You can't smoke tobacco in it, for example. So I want you to keep that in mind as we move ahead today, because we're going to be talking about things that are not what we might think of them as being. So we are going to have 4 different concepts that show up today. And I want you to keep in mind that one of them is the file itself, and the others are objects that represent that file, or ways to describe that file, but they are not that file itself. Okay? So we're going to start with the FASTA file on the disk. I think everyone here has probably received a copy of a .fa file. It was this Mycobacterium tuberculosis H37RV ASM 19595 version 2 .pep.all.fa. Everyone got a copy of that, correct? That's good news. Okay, so this file is what we call a FASTA database, but I want to point out that as databases go, it's a pretty bad structure. It's a big text file, and it has some markup in there to indicate this is a sequence entry, okay? But to speak of it as a database is already to kind of miss the fact that it's just a big structured text file. So as we think about that file, programmatically, the file sitting on the disk is just a file sitting on the disk. Programmatically, we need to have ways to describe it, and we start with the file name. One of the things that we're going to need to pass to our software is the name of the FASTA file to be handled. This name, however, I want you to keep in mind, in the same spirit of "Ceci n'est pas une pipe," is that this is a text string that gives the name of a file. It is not the file itself. Everyone good with that so far? Okay, so one is just the name of the file, the other is the file itself. These are different things. And thirdly, we're going to create a class that represents this file in memory, and that is the file object. All right, and we will use the open command to create a file object based on a file name. But only one of these things is the file itself. That is the FASTA. Okay, and then the other string that we're going to be working with would be the contents of the file. So these are the lines of text that we can see at this particular moment in time. So we're going to be treating the file as a source of lines. It's kind of a big list of lines, in fact, and we're going to handle them one line at a time as we work our way through. Everybody okay on the definitions so far? So we have the thing written to the hard disk. We have the name of that list, the name of that file, so that we can find it. We have a file object that in memory will represent the file. And finally, we have the bits of text that we're scraping out of the file. Okay? Good with that? Okay, so I think it's very important that we emphasize we are only covering text files here. So if we were in a situation where the FASTA format were writing its databases in SQLite or in MySQL databases or PostgreSQL, whatever, or Oracle databases for that matter, we wouldn't be able to read them this way. Because FASTA files are written in text, it's a whole lot easier to get at their contents, and it's one of the reasons why I chose it as an example, because it's a relatively easy kind of source to read. Hopefully, on the last day of this training, we will look at some systems that are able to treat these databases more as databases rather than as text files. We'll be looking at something called BioPython and some of the objects that are available there. But for now, we're just going to act like these are straight text files, okay? Okay, so when we read a text file, when we open it, we must tell this open command, the open function that returns a file object, what kind of opening we want to do on this file. You may, in this case, be reading this FASTA file with no intention whatever to write to it. Okay, so in this case, we're doing a read-only operation. There's no change to be made to the FASTA file by the software that just characterizes what's in it. So in our case, the read-only mode of operation is going to be great. It might be that you were writing a result that is overwritten every time you run some software. Maybe our software, the FASTA Sniffer, would create a report called FASTA Sniffer.txt, for example. And in a case like that, you might want it to just overwrite whatever result was done before by the software. You could do that with the write, the W mode. The other possibility is that you might be interested in logging the output of software over time, right? So for something like that, we would want to take special care not to delete anything that was already in the text file, but rather just glom stuff onto the end of it. If you're doing something like that, using the append mode is also is preferred. Now, I would have to say that there are 3 other modes in which you can open these files called R+, W+, and A+. I would have to say I did not get a passing grade in understanding what those are about, so maybe at some point we can turn to you to give us an explanation on those. But for now, we're going to just settle with the read-only, the write-only, and the append modes as things we're going to work with. We could, for example, write our statistical report about what we found in the FASTA file to a text file, in which case we would need to open another file with the W mode or the append mode, either way, and write that information into a file. But at present, all I'm planning to do is just to report our statistics to the screen. It's time-honored, it works. So that's what I have in mind for what we're going to do with files for now. Okay, so there are 3 commands that I think are really useful for us to work with as a starting point. The first of these, if you are in the world of object orientation, you would probably call a constructor. A constructor is a function that produces a new object from information you pass it. So in this case, the open command takes as its arguments a file name. Here, just filename.txt is what I've called it, and the mode. So whether it's R or W or A, it's going to be recorded right here. So open, as you can tell, has a return value. Now, I hope that you were able to watch the YouTube video of the session from Monday. I know a lot of people weren't able to be here. But we talked about functions and methods, particularly in that. And one of their characteristic features is that they can return something based on the information you feed them. So here, instead of returning an integer or a floating point number, we are returning an object that is a file. Okay? So having created the file, now I would note that we've already encountered 3 of the 4 things I put on that slide, right? We have the FASTA file itself, which here is referred to by the file name, and that created a file object. You see that those are 3 different things. It's a little odd that they are, but they are different things. Okay, so having created a file object, we can now run methods associated with that file object. So one of the common methods that we would use would be read line. So I would explain that text files, for a lot of historic reasons, are generally treated as a collection of lines. That might seem self-evident to you, right? I mean, you open a text file, you expect it to show up in Notepad, and there it is, line 1, line 2, line 3, line 4, all very straightforward. It's not necessarily the case that it be done that way. Back in the day, I used to do art in high school using something called an ANSI animation. And those are text files too, but you just play them back, and they don't have lines per se. But for most purposes, when we are reading text files, we tend to think of them as the first line, and then the second line, and then the third line. So there's an important characteristic about this, which is that these individual lines of the file are set apart from each other by typically some sort of end of line. Did I have that on the next slide? I don't think I did. An end of line character. Something that says, for example, this is the end of this line, return to the beginning and go to the next row on the screen. So that end of line character is how these big text files are subdivided into what we see visually as different rows of text. Okay, so having executed the read line method of the file object returns a string. Everyone sees how that would be? So each line of the file is now treated as a separate string. That gets dumped into a variable, this line. Generally speaking, having some sort of descriptive name is good, and when you have many lines and you're looping through them, it's kind of typical to use something like this line, or current line, or line I'm on, whatever you want to call it, as a descriptive variable name. And finally, it's always a good practice to close the file. Now this is, if you're a very sloppy programmer and you're just reading a bunch of text files, you can get away with not closing the file. It's rude, but you can do it. If, on the other hand, you are writing text to a file, if you end your program without having closed the file, you're going to lose content. You have sent 50 lines to be written to the file, but if the program just ends abruptly and it doesn't close the file, it doesn't flush the buffer and get all that stuff actually onto the disk and properly seal off the file. So if you're writing stuff to a text file, do not forget to run the close function, or you'll have all kinds of weird truncated output and you can't figure out why. It's because you didn't close the file. All right. So these are just 3 commands: open, readline, and close. And you might see something like readline 3. Here I've used readline with nothing in here. Something like readline 3 will return like the third line of the text file. So again, the software is quite good at, the programming language Python is quite good at handling things as lists. And we're going to see a particular example of that in this case. Now you'll recall that when I made our outline, I specified, when we looked at our flow chart on the very first day, we were going to read a line, then start a while loop, which said, while the next line is something to be worked with, continue, and then read a line, and then come back to this decision point. That was the loop we had constructed. In this case, we're using an even simpler syntax that Python makes available. This is kind of shocking to me because I'm so used to working in Java or C++. So here we can open our file name in the read mode. You can see that we can use this construct that we talked about on Monday, the for loop. So the file object, in this case, is being treated as a list, and that list comprises all of the different lines in that text file. And so the software is being told to loop this line through that list of lines so that we get each one independently. Now here I've just printed that line. There are simpler ways to do stuff like this. But you can see that in this case, the for loop is going to execute on each line appearing within that text file, allowing us to operate on each one independently. And because we are very clean and well-mannered people, we will close the file object at the end. Okay, do you always close your files, Brigitte? She does not. Okay, so she's a cowboy programmer. Watch out for her. Okay, I don't think I have any other slides here, so let's look at the source code. I'm going to make our font sizes get a little better here. so that we can look at this better. All right, I think 16-point consolus should get it done. Here we go, consolus. Okay, blow that up big. Okay. Great. Now, oh gosh, it's not going to show the left edge of the screen, so I'm going to scoot it over just a tiny bit. Okay, that's better. Great. So this is very much like the code in goal number 1. So what I've done is to clean up that code a little bit and add on just a quick file reader. Okay. So we're still importing system because we're going to use the command line arguments to figure out which FASTA file is to be processed in this run. Remember, it's kind of bad programming practice to write into the code what file it's operating on. You want people to be able to use this code for something other than this particular database. So accepting input of which file they want analyzed is good programming practice. You'll note that I've cleaned up this code so that it only checks to see if there's any file containing the short phrase .fa. You might remember that in goal 1, we checked to see if the phrase .fasta appeared or .faa appeared. But then I realized that the sequence database I handed you actually has a .fa extension. So that wouldn't have been caught by the original code we wrote. So I decided that I would simply look for any file that contains .fa. .fasta will still find that phrase, even though it's not the whole end of the file name. What else did I change here? I decided that our eventual name will not be goal 1 or goal 2, but rather FASTA Sniffer py. So I've included that in its file name here. Is Sniffer an okay name for something that makes stats off a FASTA file? Good news, good news. Okay. So all of that is largely just the stuff that we had from goal 1 cleaned up a little bit. Now, this is the new stuff. So can someone talk to me about what this command does? It's one of the most important in the new code. What is this FASTA? Does anyone remember? We can look upwards a little bit if we want. This FASTA. You can see right here that we're setting the variable this FASTA to be whatever the last sequence database was that was in the command line. So if you give it 3 or 4 FASTA databases, it's only going to process the last one that you provided. Okay, so this FASTA is a string which represents the file name, ideally. And we're running the constructor open on whatever string the user has provided, and we're trying to open that as a text file in read mode. Everyone spotted that, I think, from the slides. I'm just putting words in your mouth here. Now, I'm going to start by initializing some counters. One of the things that we wanted to do to characterize the FASTA file that we were working with was to say how many different entries are there in this database. Whether it's a nucleic acid database or an amino acid database, we can still count how many entries are in there by how many lines are accession lines. I see that there's a question up in the back. Can I help?
That's not a question.
Not a question. Okay, that's cool. I'm glad to help where we have this. So the goal is not that you think my code is amazing, but that you can write this yourself. Okay. So we've now said the accession count starts at 0. We open the file in read-only mode. Now, here we're going to use this nifty syntax that Python makes available to us to just for our way to loop through each line of the sequence database one after the other. Now, I'm going to pause for a moment. We're going to move to a different file, but I want you to keep in the back of your mind what mystery this might be intended to solve. I think we've already looked at things like greater than and less than operators, but this equals business, I don't think you've seen before. Equals is intended to ask a question of two things. Do these have the same value? So when we run does 5 equal 5, we should get back what? For those who watched the video yesterday, you probably know that if you say, if you run a comparison like this on two values, one of the most likely outputs is a Boolean. So we can look at a quick example of that, in fact. So let me just pop open my Python. All right, let's just open that critter. We'll do it kind of wild and woolly here. All right, I need to make those fonts big enough that you can see them. All right, and a little consoles, 18 point, nice and huge. Woo, all right, that's fine. Get on with it. Okay, so remember that in the interpreter, we can just type our commands live and get feedback right away. So let's try something obvious like 3 is less than 5. You see it replies with true. If I say 5 is less than 3, I get the answer false. What happens if I say 3 is equal to 5? False. But 5 is equal to 5. You can also shake this up a little bit with some unusual ones. So you could say 3 is less than or equal to 5. Oh, good. I wasn't sure about the syntax on that one. What about not equal? Does that work? Oh, how lovely. So I can say 3 is not equal to 5. Exclamation. Oh, like I did. Oh, you can't read that at all. Oh, Lordy. I am so sorry. Here, let me try fixing that up a little bit more. Okay. Feel free to tell me when I'm just messing up like that. All right. Is that a little better? I'm sorry, white on black is not working so well. So we did 3 is less than 5, and it didn't say how much less it is, right? That would be an integer output. It could say 3 less than 5 and return a value of 2, for example. But that's not how these commands are encoded. These operators return a Boolean value. So a 3 less than 5 is true. 5 less than 3 is false. 3 equal 5, false. Everyone sees that. Okay, so when we use the equals operator, we're asking the question, are these things different? Now that's quite different than saying 3 equals 5. Do you see why that's an error? To say 3 equals 5 is to ask a question. Does 3 equal 5? That's why its value is false. But this is to say, I am creating a variable named 3, and I'm setting it equal to 5. And the software is saying, 3 isn't a valid name for a variable. Okay? If I have created a variable 3 equal to 3, I can just type 3 by itself. We see it's equal to 3. If I say 3 equals 3, it returns true. Because here we're asking the question, does my variable with the value of 3 have the same value as the number 3? But look what happens if I do something like 3 equals 5. Does it say true or false? It does not. Because when I've typed 3 equals 5, in this case, not equals, we've told it to change the value of 3 to 5. Okay, now that I've really confused everybody, I said today was going to be about things that are not the thing they represent, right? So equals asks the question, are these things the same value? Okay. Now there was another little, another odd thing that I did here with this line, square brackets 0. I think everybody has, if you've watched the video from yesterday, you know that Python has a real proclivity for starting with 0, right? So if we look at this code and say we want a range of 10 values, has everyone seen the range operator or the range function? I think so. We see that range 0 to 10 results. If I say print everything in range 10. Oh, I've forgotten how to do this. Sorry, I want to print these to string. Is that right? Sorry, string range 10. One more. I'm still not getting there. Do I need to do the for loop on this? Oh, okay. Well, sorry about that. It's okay. In any case, the here we go. For counter in range 10. Oh, I forgot my colon here. Tab in, print, counter. There we go. Okay, so here we've set up a for loop that goes through all the values in range 10. We see it starts at 0, but is 10 included in the list? It is not. Because there are 10 items in 0 through 9, and counting always starts at 0 unless you specify otherwise. So let's look at how this works if we use the square brackets. So I'm going to create something called this string equals Python is confusing. No, that's too negative. Is incredible in the sense that it's not credible. Okay, so this string now has that value. But you see, we can also treat this as an array of characters. So if I want to see the first character of this string, I can say square brackets around a 0. Because remember, all counting starts with 0. And so the first character that pulls out of it is a capital P, because that's the first character here. If I want to make reference to the second character, I can just change that to a 1. Or grab out the 12th, if I feel like it. Okay? So when you have a string like this, you can treat each letter out of that string using something like square brackets to index out a particular letter. And that's what I did in this line. So I know I'm really belaboring this line a lot, but I want to make sure everybody gets the logic underneath it. So we have a string called this line. It represents this individual line that we've grabbed out of the FASTA file. And square bracket 0 means we only care about the first character in that line. This double equals says we want to compare its value to, and then we've got double quotes around the greater than symbol. Now, if you're looking at FASTA files every day, it's probably immediately obvious why we would do that. But I don't want to take anything for granted like that. So I am going to open Mycobacterium tuberculosis. There we go. This is the content of the Mycobacterium tuberculosis FASTA database. You see, it's just a big text file, so we don't have to be very stressed about that. And I would note that there are two kinds of lines represented here. We have lines that start with greater than symbols, and that always means this is the start of a new sequence. And we have lines that start with other characters. Those represent sequence. Now, you might be tempted to think that not just the first line contains the description, but this is actually all one big text, one big line of text. That's necessarily part of the format. So these lines are accession values and descriptions, and the other lines are all sequence. So for the first metric we're going to compute today, we're simply going to ask how many accession numbers are there in this database. And the only thing we have to know to do that count is that all accession lines start with a greater than symbol. All good so far? Okay, great. So let's come back to the other tool here. I'm going to pop over to that buffer. Great. Okay. So having set up this loop where each line of the FASTA file is going to be sniffed separately, we can ask, does this line begin with, that's what this square brackets is all about, the greater than symbol. If it does, it's an accession. If it doesn't count. We don't need to worry about it. We don't need to know how many sequence lines there are, just how many different entries there are in the database. So if that condition is correct, we're going to increase the accession count. Now, as I mentioned in the recording yesterday, in C++ you might write accession count plus plus. But this is Python, and Python does it differently. Instead it uses plus equals 1, which might seem a little weird at first, but accession count already has a value. We're just going to increase it by 1. So one way to read this is that accession count is set to the current value of accession count plus 1. Is that all right for everybody? Okay. So having done this, do we need to do anything if the first character is not a greater than symbol? Not for today's goals. Okay? Later on, we will want to do some things, right? One of the things we want to do is count how many times each letter appears in the sequence. But for now, we don't care. We're only going to pay attention, we're only going to count those lines that start with greater than symbols. And all we need to do is add to our counter. So there is no else, and there is no elif stuck onto this. We just need to check, is this line starting with a symbol? If so, add to our count. So that if is all finished, and because there's nothing else indented, it's going to continue on with our for loop until we hit the end of the file. So this is a really clean syntax for reading text files. I've worked in a lot of languages, and most of them have a lot more cruft built around the process of reading a file. This is about as clean as you're ever going to see it. So I think it's kind of an impressive feature of Python that can be read this easily. Okay. And I note it is polite to ensure each open file is also closed. I don't mean to emphasize this 5 and 6 times, but seriously do it. Okay, close. And then at the end, I feel it's polite, having generated this number, to actually tell people what we got. So we have some accession count. We can then print how many accessions we found. Does anyone remember why we have a str on here? Is that we want to make our count really strong? String it, exactly. We want to construct a string from this integer that we've accumulated. And then, because we're being very, very polite, we'll even tell the user that we're finished. All done. These might seem like very silly features, but honestly, users feel a sense of contentment when the software says, this is going to take a minute, or, okay, now I'm all finished. So it's not a bad idea to write them in. Okay. So, we can now run this code. I am sitting inside the interpreter here, and that's not quite where I want to be. So instead, I'm going to run this on a command prompt. So I've opened my command prompt here. Will you be able to see that? I'm going to make those fonts even bigger. I'm a man who can't be stopped where large fonts are concerned. 28-point font. Can we read that? Oh yeah, there we can. Okay, I'm going to move to the directory that contains the source code. Here we go. All right. Now I need to get my Python interpreter in place. So I type Python. Here it is. I need to open its file location because they hide it behind so many crazy places. This is where running IPython would be a lot kinder, I think. This is actually a shortcut, so I need to open its file location as well. And there's Python exe, hiding just where everyone expects it to be. David tab app data local programs run Python. Yeah, great. Well done, guys. Let's hear it for usability. Okay, so Python exe is here. That's great. Oh, it's not Q, it's quit. Okay, now I need to tell it what script am I going to run. And that one is called 2019-0515, where'd the rest of it go? Yeah. Gold 2 Python. Okay, yeah, great. Now, if I just run that with nothing else on it, you see we've got this problem. I didn't provide it a name of the FASTA database. It says no FASTA provided exiting, right? Because you remember we wrote that considerate bit of code in there that said what to do if no FASTA file were provided. Well done us, right? So now we will try running it. Remember, you can just repeat the last command you typed with the up arrow. That's very, very handy to remember. Okay, and now This time we will give it mycobacterium blah, blah, blah. Because I'm a lazy programmer, I type my and hit tab. Because I can't be bothered to write that all out. That's too much. Okay. Does anyone want to take odds on whether we're going to crash and burn here? Sune is shrugging her shoulders. That's so sad. Do you think I tested it? I maybe tested it. It's possible. Not on this computer. Not today. I made some changes. Who knows? I'm going to hit enter. Oh, look at that! Brilliant. Okay, so FASTA Sniffer has announced itself as version 0.2 because this is, after all, the second time we've worked on it. Dave Tabb, Stellenbosch University. I put the GNU Lesser General Public License on another line. This is the FASTA we will use. In other words, it's interpreting what I've passed it on the command line. Here's the file name, all very good. It runs very quickly. Did you notice there was no delay? It takes 0 time to read 4,000 protein sequences. Pretty impressive. So we found this many accessions inside, 4,018. All done. You don't write all done at the end of your software?
I just think you're taking my fast. I think I'm going to write it at the end of all my code.
That's great. Okay, now I don't have more that I really want to push us on today, but I'm going to tell you on Friday, we're going to talk about exceptions. And to give you an example of why, I'm going to make some modifications here. Not to the code. I'm going to change, well, tell you what, we'll start by just coming in here and saying, did you see what I did? I've now made an assumption. The true file ends in .fa, but I forgot, so I wrote FASTA on there. What's going to happen? If you're a user, if you've never written a line of code in your life, how do you feel when you see all of this stuff show up? Trace back most recent call last file blah 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 in module. File not found error, no such file or directory. If you're not a programmer, that's not very intuitive. So on Friday, we're going to talk about something called exceptions, because there are better ways to handle these errors than simply to pass them back to your user and say, I don't know what you did wrong. Okay. Are there questions about what we did today? Is there confusion about about opening to create a file object? Excellent. Great. Great. Brigitte's going to return to us on Friday. That's good news. Any questions about opening a file? Are there any questions about what we did with that for loop? Why we can just treat the file as a list of lines rather than one big entity? Okay. Any questions about how equals is different than equals equals? Great. You guys are in good shape then. I do hope, if you didn't see the lecture on Monday, that you will watch the video. We got it down to 45 minutes on the retake, so I think it will help if you're running into problems with loops, or if, elif, and else, or functions versus methods. Okay? Great. Well, I will go ahead and stop the recording now, and then we can take any questions that remain.